that's what happens when you have conductors next to each other. When you put conductors close together, they can heat the other conductors. If they're in a raceway, they can release the ambient, and they also will prevent the other conductors from dissipating heat more freely. So it's a little harder when you're in a tight bundle. So you need to take those kind of things into account. If there's more than a number present, again, the main requirement or main default for the ampacity table is 3 current carrying conductors. So taking that example that I've been carrying a little further, say you had 6 conductors in a raceway. You'd go to table 31015B3A, and that would require a derating of an additional 80%. So you've already derated it down because of the temperature. You're derating it down again now because you have too many conductors in the raceway. So the 3 gauge 60 degree C wiring and also now the 6 gauge 90 degree wiring don't meet the requirements. You can't use any one of those because you'd exceed the temperature rating. So now you'd have to drop down to a 2 gauge for 60 degrees C or 4 for the 90 in order to carry that 60 amps you originally started at.
So a lot of factors involved here that come into this. There is the ambient temperature, which is sort of the overview of our discussion today and how that affects your wiring methods and your materials. But you got bundling, you got other things. There's a lot of factors, conditions of use that go into this.
Right, and it's easy to overlook some. You know, you may forget that, you know, you're running by a heater if you're in an industrial place, if you got a wave soldering machine or something like that. Or, you know, if you're in a home and you're running conductors, you know, next to your furnace, you might have to take these things into account. And also what they plug into, what you're terminating these conductors on is another one of those conditions of use. You need to know what you're going into, which we can discuss now if you want.
Yeah, let's talk about, you want to go into Article 110 and electrical connections? Yeah, let's talk about that.
So we're going to hop out of Article 310 and we're going to go to 110 because it really does have some temperature requirements as well, and this has to do with the terminations. When you're terminating conductors to a terminal block or whatever you're connecting in a screw set screw, you need to make sure that your conductors are compatible with that kind of termination. And you also need to be concerned with the size. Certain terminations have certain sizes. So we've already adjusted from a 6 down to a 2. Your device that you were planning on using may not accept a 2 if you're using a 60-degree insulation. So now you got a problem. You thought you were going to install with a 6. You bought this piece of equipment. Now you can't plug it in because you ended up with a 2 because of the adjustment factors. So the temperatures of terminals, you have them in luminaires, circuit breakers, lots of things have temperature ratings when you look at them. A lot of circuit breakers will say 75, 90, they'll have dual ratings as well. And again, that's the temperature that you can't exceed for that termination.
Okay.
So 110.14 comes out and says, or actually 110.14C1 says you have to meet the requirements for your termination. And you use the table 31015B16, in our case, to determine what that current would be.
Okay.
So if you pass 65 or 95 amperes through a conductor that was 60 degrees C, you would exceed that rating. Plugging that same conductor into a terminal that's rated 60 degrees C would exceed that rating. So you have to look at the termination temperature on 31015B16. So say, you know, we're going through and you had the 4 AWG 90 degree C conductor. That has a starting ampacity of 95 amps. When we did all this derating that we did, it went down to 69.1 amps. You could plug that 90 degree C conductor that has an ampacity rating of 69 amps into the 60 degree termination for a 4 gauge, because the ampacity of the 4 gauge is 70 amps. So this gets a little confusing. So if you could put 70 amps through something that's rated 60 degrees C with a 4 gauge, it's not going to get hotter than 60 degrees C.
Okay.
So you can use your 90 degree C conductor, even though it's ampacity 69, because you're only carrying 60 amps. Right. So you have to take all these things into account, and it kind of sounds a little bit confusing, but this is how you're able to use a higher insulation temperature conductor for derating and adjustment factors. It allows you to use this 90° C 4 gauge for a 60° C termination.